Hello, I'm SA, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Alan Kay stands as a monumental figure in the history of computer science, a visionary whose ideas have fundamentally reshaped how we interact with technology. His contributions extend far beyond mere innovation. They represent a profound shift in our understanding of computing's potential, particularly in areas such as object-oriented programming. Kay's early work laid the groundwork for many of the software development practices prevalent today. The seeds of Kay's groundbreaking work can be traced to the burgeoning field of computer graphics and human-computer interaction in the 1960s. One particular project served as a catalyst. Ivan Sutherland's Sketchpad. Sketchpad, developed in 1963, was a revolutionary system that allowed users to interact directly with a computer through graphical manipulation. Sutherland's system demonstrated the power of visual interfaces and interactive computing, offering a glimpse into a future where computers were tools for creative expression rather than mere calculators. Sketchpad's influence on Kay was profound. He recognized the potential for computers to become more than simply machines for processing data. He envisioned them as dynamic environments for creation and exploration. However, Kay also perceived limitations in Sketchpad's approach. While Sketchpad allowed for the creation and manipulation of graphical objects, it lacked a general framework for representing and interacting with diverse types of information. It also lacked the facilities to create new types of objects easily. Kay sought to extend Sketchpad's concepts towards a more generalized and powerful paradigm. This quest led Kay to the concept of object-oriented programming, a revolutionary approach to software development that structures a program around objects, self-contained entities that encapsulate data and behavior. Kay, along with his colleagues at Xerox PARC Palo Alto Research Center, pioneered this paradigm, culminating in the development of Smalltalk, one of the first true object-oriented programming languages. Smalltalk represented a radical departure from traditional programming languages. Instead of focusing on procedures or data structures, Smalltalk centered on the concept of objects interacting through message passing. In Smalltalk, everything is an object, including numbers, strings, and even program code. Each object has its own state data and behavior methods, and objects communicate with each other by sending messages. One of the key innovations of Smalltalk was its dynamic typing system. In dynamically typed languages, the type of a variable is checked at runtime rather than at compile time. This allows for greater flexibility and expressiveness as objects can be created and modified on the fly. It also allows for more rapid prototyping and experimentation, as developers can quickly iterate on their code without having to worry about strict type constraints. Message passing, another cornerstone of Smalltalk, provides a powerful mechanism for abstraction and modularity. When an object sends a message to another object, it does not need to know the internal details of how the receiving object will handle the message. It only needs to know that the receiving object understands the message and will respond appropriately. This allows for greater flexibility and coupling, as objects can be modified or replaced without affecting other parts of the system. Smalltalk's influence on the software industry was immense. It introduced many developers to the concepts of object-oriented programming, sparking a revolution in software design. While Smalltalk itself never achieved widespread commercial success, its ideas were adopted and adapted by many other languages, including C++, Java, and Python. These languages, which now dominate the software landscape, owe a significant debt to Kay's pioneering work. The immediate impact of Smalltalk can be seen in the development of graphical user interfaces. Smalltalk's object-oriented approach made it particularly well-suited for building interactive applications with visual elements. The language's message passing mechanism allowed for easy handling of user events, such as mouse clicks and keyboard presses, while its dynamic typing system allowed for rapid prototyping of new interface elements. Adele Goldberg, a close collaborator of Kay's at Xerox PARC, played a crucial role in promoting and popularizing Smalltalk. She developed many of the key programming environments and user interfaces for Smalltalk and authored influential books and articles that helped to spread the language's ideas to a wider audience. Her work was instrumental in demonstrating the practical benefits of object-oriented programming and inspiring a new generation of software developers. The legacy of Smalltalk extends far beyond its direct influence on programming languages. The language's emphasis on simplicity, elegance, and expressiveness has influenced the design of countless software systems. Its focus on objects and message passing has helped to shape the way developers think about software architecture, promoting modularity, reusability, and maintainability. Moreover, Smalltalk's dynamic typing system has had a lasting impact on the field of programming language design, while static typing systems, which check types at compile time, offer certain advantages in terms of performance and safety, dynamic typing provides greater flexibility and expressiveness, allowing developers to write code that is more concise and easier to understand. The debate between static and dynamic typing continues to this day, with many modern languages incorporating elements of both approaches. The reception of Smalltalk was initially mixed. Some developers embraced its radical departure from traditional programming paradigms, while others were skeptical of its dynamic typing system and its reliance on message passing. Critics argued that Smalltalk's dynamic typing could lead to runtime errors that were difficult to debug, while its message passing mechanism could make code harder to understand and optimize. However, over time, many of these criticisms were addressed. Advances in compiler technology and debugging tools made it easier to identify and fix runtime errors in dynamically typed languages. Moreover, developers learned how to write Smalltalk code that was clear, concise, and easy to maintain. As a result, Smalltalk gained a dedicated following, and its ideas were gradually adopted by the mainstream software industry. Kay's work on Smalltalk was directly influenced by his exposure to the ideas of computer pioneers such as J. Licklider and Douglas Engelbart, both of whom envisioned computers as tools for augmenting human intellect. Licklider, in his seminal paper Man Computer Symbiosis, argued that computers should be designed to work in partnership with humans, complementing their strengths and weaknesses. Engelbart, through his work on the ON line system NLS, demonstrated the power of interactive computing for enhancing collaboration and productivity. Kay drew inspiration from these visions, seeking to create a programming language that would empower individuals to create and explore new ideas. The impact of Kay's work on others is undeniable. The concepts he pioneered in Smalltalk have become fundamental to modern software development. Object-oriented programming is now the dominant paradigm for building complex software systems, and languages like Java, C++, and Python owe a significant debt to Kay's vision. His emphasis on simplicity, elegance, and expressiveness has influenced the design of countless software systems, promoting modularity, reusability, and maintainability. Kay's legacy as a computer scientist and visionary is secure, and his ideas continue to shape the future of computing. He provided a powerful framework for thinking about software design, one that continues to inspire developers today. Alan Kay's intellectual journey took a pivotal turn as he grappled with the potential of personal computing. Building upon the interactive computing visions pioneered by thinkers such as Sutherland and Douglas Engelbart, Kay began to envision a truly personal computational device, one that would empower individuals to explore, create, and learn in unprecedented ways. This vision crystallized into the Dynabook concept. The Dynabook was proposed as a dynamic book, a personal computer for children of all ages. It was conceived as a portable device, roughly the size and weight of a notebook, with a high-resolution display and a user-friendly interface. This device was intended to serve as a window into a world of knowledge and creativity, enabling users to access information, create media, and communicate with others. The Dynabook was more than merely a piece of hardware. It was a complete learning environment designed to foster exploration, discovery, and personal growth. Kay's vision for the Dynabook was deeply influenced by his experiences at Xerox PARC. There, he was exposed to cutting-edge technologies such as the Alto personal computer, the Smalltalk programming language, and the graphical user interface. These technologies provided Kay with the tools and inspiration to realize his vision of a personal computer for everyone. The Alto, in particular, demonstrated the power of interactive computing and the potential of graphical interfaces to make computers more accessible and intuitive. The Dynabook concept was unique in its synthesis of advanced hardware and software capabilities with a user-centered design philosophy. Kay understood that the true power of a personal computer lay in its ability to empower individuals to express themselves and to learn in their own way. He envisioned a system that would be simple to use, yet powerful enough to support a wide range of activities, from writing and drawing to programming and simulation. A key aspect of the Dynabook concept was its emphasis on software. Kay believed that the software environment was just as important as the hardware platform. He envisioned a system that would be highly customizable and extensible, allowing users to tailor it to their own needs and interests. Smalltalk, the object-oriented programming language developed at Xerox PARC, played a crucial role in this vision. Smalltalk provided a powerful and flexible environment for creating interactive applications, and it allowed users to easily modify and extend the system's functionality. The Dynabook's immediate impact was primarily conceptual. While a fully realized Dynabook device was never commercially produced during Kay's tenure at Xerox PARC, the concept itself had a profound influence on the development of personal computing. The Dynabook served as a blueprint for future generations of laptops, tablets, and other mobile devices. Its emphasis on portability, user-friendliness, and software customization helped to shape the design of these devices and to make them more accessible to a wider audience. One of the most significant contributions of the Dynabook was its focus on education. Kay believed that personal computers had the potential to revolutionize education by providing students with access to a wealth of information and empowering them to learn at their own pace. He envisioned the Dynabook as a tool for fostering creativity, critical thinking, and problem-solving skills. This vision influenced the development of educational software and the integration of computers into classrooms around the world. The Dynabook concept also had a lasting impact on the field of human-computer interaction. Kay's emphasis on user-centered design and his focus on creating intuitive interfaces helped to shape the way that computers are designed and used. The graphical user interface, which was pioneered at Xerox PARC and heavily influenced by the Dynabook concept, has become the dominant paradigm for interacting with computers. Later, the Dynabook vision inspired numerous researchers and developers to pursue the dream of a truly personal computer. Allen's ideas found expression in the development of early laptop computers during the 1980s. While these early laptops were bulky and expensive compared to Kay's vision, they represented a significant step toward the realization of the Dynabook concept. The development of tablet computers in the early 21st century further advanced the Dynabook vision. Tablets offered a level of portability and user-friendliness that was closer to Kay's original concept, and they have become increasingly popular as tools for education, entertainment, and productivity. The critiques leveled against the Dynabook concept often centered on its technological feasibility. In the 1970s, the hardware required to build a device with the capabilities of the Dynabook was simply unavailable or prohibitively expensive. Critics also questioned the practicality of Smalltalk as a programming language for widespread use. Despite these critiques, the Dynabook concept continued to inspire researchers and developers, and many of its key features were eventually realized in later generations of personal computers. The reception of the Dynabook concept was largely positive, particularly within the research community. Many computer scientists and educators recognized the potential of the Dynabook to transform education and empower individuals. Kay's vision was also well received by the popular press, which hailed the Dynabook as a glimpse into the future of computing. Allen's work on the Dynabook directly influenced individuals such as Adele Goldberg, who played a key role in the development of Smalltalk and its application to educational software. Goldberg's work on Smalltalk directly enabled the creation of interactive learning environments that embody the Dynabook's vision of empowering children to learn through exploration and discovery. Conversely, Kay was significantly influenced by J. Licklider, whose vision of man-computer symbiosis shaped Kay's understanding of the potential for computers to augment human intelligence and creativity. Licklider's ideas provided a philosophical foundation for the Dynabook concept, emphasizing the importance of creating computers that were both powerful and easy to use. The Dynabook's influence extends to those who sought to build upon its vision in designing early laptops and personal computing devices. Individuals such as Bill Moggridge, who designed the G-RID Compass, one of the first laptop computers, drew inspiration from the Dynabook's emphasis on portability and user-friendliness. The G-RID Compass, while different in many respects from the Dynabook, demonstrated the feasibility of building a portable computer and helped to pave the way for future generations of laptops. In summary, Alan Kay's Dynabook concept was a visionary idea that had a profound influence on the development of personal computing. While a fully realized Dynabook device was never commercially produced during Kay's tenure at Xerox PARC, the concept served as a blueprint for future generations of laptops, tablets, and other mobile devices. Its emphasis on portability, user-friendliness, software customization, and education helped to shape the design of these devices and to make them more accessible to a wider audience. The Dynabook remains a testament to the power of visionary thinking and its ability to transform the world. Alan Kay's influence extends far beyond the realm of hardware and software design, reaching into the crucial domain of computer science education. He recognized early on that the true potential of computing resided in its ability to empower individuals, especially children, to explore, create, and learn. This conviction fueled his dedication to developing innovative educational approaches and advocating for a more holistic vision of computing education. Kay's perspective arose from a deep concern regarding the prevailing methods of teaching computer science, which he viewed as overly focused on technical details and rote memorization. He believed that this approach failed to cultivate a genuine understanding of fundamental concepts and stifled creativity. Instead, Kay championed an educational philosophy centered on fostering intuition, exploration, and a deep appreciation for the underlying principles of computation. A key aspect of Kay's educational philosophy involves the idea of powerful ideas. He argued that education should focus on conveying these ideas, which are fundamental concepts that can be applied across a wide range of domains. In the context of computer science, these powerful ideas might include abstraction, recursion, or modularity. By grasping these core principles, students can develop a more flexible and adaptable understanding of computing, enabling them to tackle complex problems and create innovative solutions. Kay's work with the Viewpoints Research Institute exemplifies his commitment to transforming computer science education. This institute, which he co-founded, has been instrumental in developing new educational tools and methodologies based on his principles. The Institute's research has focused on creating learning environments that encourage exploration, experimentation, and collaboration. One of the Institute's key contributions involves the development of innovative programming environments designed specifically for children. These environments are characterized by their simplicity, intuitiveness, and emphasis on visual programming. By using visual programming languages, children can learn the fundamentals of programming without having to grapple with the complexities of traditional text-based languages. This approach enables them to focus on the underlying logic and structure of programs, fostering a deeper understanding of computational thinking. Kay's emphasis on conceptual understanding over technical details has had a significant impact on the field of computer science education. He argued that students should first grasp the fundamental principles of computation before delving into the intricacies of specific programming languages or hardware architectures. This approach ensures that students develop a solid foundation of knowledge that can be applied to a wide range of computing contexts. His influence can be seen in the work of numerous educators and researchers who have adopted his approach to computer science education. These individuals have developed new curricular, teaching methods, and educational tools that reflect Kay's emphasis on conceptual understanding and creative exploration. Their work has helped to make computer science education more accessible and engaging for a wider audience. Seymour Papert, a prominent figure in educational technology, was deeply influenced by Kay's ideas. Papert's work on Logo, a programming language designed for children, reflects Kay's emphasis on creating learning environments that encourage exploration and experimentation. Logo's turtle graphics, which allow children to control a virtual turtle on the screen, provide a visual and intuitive way to learn the fundamentals of programming. Mitchell Resnick, a professor at the MIT Media Lab, has also been influenced by Kay's work. Resnick's research focuses on developing new technologies and activities that empower children to become creators, designers, and inventors. His work on Scratch, a visual programming language designed for young people, builds upon Kay's ideas about creating accessible and engaging programming environments. Scratch's drag-and-drop interface and its emphasis on storytelling and animation make it easy for children to create interactive projects and share them with others. Kay's advocacy for a more holistic approach to computing education extends beyond the classroom. He believes that computing should be integrated into all aspects of education, from mathematics and science to the humanities and the arts. This integration, he argues, can help students develop a more comprehensive understanding of the world and prepare them for the challenges and opportunities of the 21st century. His vision aligns with the growing recognition of the importance of computational thinking skills in all fields. Computational thinking involves the ability to break down complex problems into smaller, more manageable parts, to identify patterns and relationships, and to design and implement solutions using computational tools and techniques. These skills are increasingly valuable in a wide range of professions, from engineering and medicine to business and education. Kay's philosophical viewpoints on computing are deeply rooted in his belief in the power of human creativity and innovation. He sees computing as a tool that can amplify human intelligence and enable individuals to achieve their full potential. This perspective informs his advocacy for user-centric design, which emphasizes the importance of creating technologies that are intuitive, accessible, and empowering. His emphasis on simplicity and elegance in design reflects his belief that technology should be subservient to human needs. He argues that technology should be designed to enhance human capabilities, not to replace them. This perspective has had a significant impact on the field of human-computer interaction, which focuses on designing technologies that are easy to use and that meet the needs of users. Alan Kay's intellectual journey has been characterized by a relentless pursuit of innovation and a deep commitment to education. His contributions to computer science, particularly his work on object-oriented programming, the Dynabook concept, and his educational philosophy have had a profound impact on the field. His vision of computing as a tool for empowering individuals and fostering creativity continues to inspire researchers, educators, and designers around the world. Alan Kay's multifaceted contributions to computer science represent a profound and interconnected vision, one where technology serves as a powerful tool for human empowerment and learning. His work on object-oriented programming, the Dynabook concept, and his educational philosophy are distinct yet deeply intertwined facets of this overarching goal. Object-oriented programming, as envisioned by Kay, moved away from the procedural paradigms that dominated early computing. It offered a new way to structure software, modeling it as a collection of interacting objects, each encapsulating its own data and behavior. This approach, inspired by the biological metaphor of cells communicating through messages, promoted modularity, reusability, and a more intuitive way of representing complex systems. The Smalltalk programming language, a direct outcome of Kay's work, exemplified these principles. Its dynamic typing, reflective capabilities, and focus on simplicity made it a powerful tool for exploring new programming paradigms and building interactive systems. The influence of Smalltalk is evident in many subsequent object-oriented languages, including Java and Python, which adopted and refined many of its core concepts. The object-oriented approach allowed for code to be organized in a more manageable and understandable way, which was a significant advancement in software engineering. The Dynabook, Kay's vision of a personal, portable computer for children, was far more than a mere hardware specification. It was a conceptual framework for a learning environment, one where children could actively explore, create, and share knowledge. The Dynabook was intended to be a dynamic book, capable of adapting to the needs and interests of its user. It would provide access to a vast library of information, tools for creating multimedia content, and a platform for communicating with others. While the Dynabook itself never materialized in its original form, its influence can be seen in the development of personal computers, tablets, and educational software. The idea of a computer as a tool for learning and exploration, central to the Dynabook concept, has shaped the design of educational technologies for decades. The emphasis on user-friendliness and accessibility, also key aspects of the Dynabook vision, continues to drive innovation in human-computer interaction. Kay's educational philosophy, deeply rooted in the constructivist learning theory, emphasized the importance of active learning and exploration. He believed that children learn best when they are actively engaged in the learning process, constructing their own knowledge through experimentation and discovery. This approach contrasted sharply with traditional models of education, which often rely on rote memorization and passive learning. Kay advocated for the use of computers as tools for empowering children to explore complex concepts, solve problems, and express their creativity. His work on programming environments for children, such as Logo and Edoes, reflected this philosophy. These environments provided children with a simple yet powerful way to create interactive simulations, games, and animations, fostering their understanding of computational thinking and problem-solving skills. The impact of Kay's educational philosophy can be seen in the growing emphasis on project-based learning, computational thinking, and the use of technology in education. A critical evaluation of Kay's legacy reveals the enduring relevance of his ideas in an increasingly complex digital world. His emphasis on simplicity, elegance, and user-centric design remains highly pertinent in a world saturated with technology. The principles of object-oriented programming, pioneered by Kay and his colleagues, continue to underpin much of modern software development. The Dynabook vision, while never fully realized, continues to inspire designers and educators to create technologies that empower individuals and foster creativity. His educational philosophy, emphasizing active learning and exploration, remains a guiding principle for educators seeking to engage students in meaningful learning experiences. One of the key strengths of Kay's work is its holistic nature. He viewed technology, education, and human development as interconnected elements of a larger system. He understood that technology alone is insufficient to transform society. It must be coupled with a deep understanding of human needs, learning processes, and social dynamics. This holistic perspective is particularly relevant in today's world, where technology is rapidly transforming every aspect of our lives. As we grapple with the challenges and opportunities presented by artificial intelligence, virtual reality, and other emerging technologies, Kay's emphasis on human-centered design and ethical considerations becomes ever more important. The initial reception of Kay's ideas was mixed. Some in the computer science community initially viewed object-oriented programming with skepticism, considering it an unnecessary complication. Others questioned the feasibility of the Dynabook, viewing it as an unrealistic and expensive dream. His educational philosophy also faced resistance from those who favored traditional methods of instruction. However, over time, Kay's ideas gained wider acceptance as their benefits became increasingly apparent. The success of object-oriented programming in simplifying software development, the growing popularity of personal computers and tablets, and the increasing emphasis on active learning in education all contributed to a greater appreciation of Kay's vision. Kay's work was directly influenced by a number of prominent thinkers, including Seymour Papert, a mathematician and computer scientist known for his work on Logo, and Jerome Bruner, a cognitive psychologist who emphasized the importance of discovery learning. Papert's work on Logo provided Kay with a concrete example of how computers could be used to empower children to learn through exploration. Bruner's theories on cognitive development influenced Kay's educational philosophy, shaping his belief that children learn best when they are actively engaged in the learning process. Kay's work, in turn, has had a profound influence on countless individuals and organizations. His ideas have inspired researchers, educators, and designers around the world to create innovative technologies and learning environments. His influence can be seen in the work of Alan Cooper, a software designer known for his advocacy of user-centered design, and Mitch Resnick, a computer scientist who developed Scratch, a visual programming language for children inspired by Logo. The impact of Kay's work extends beyond the field of computer science, influencing fields such as education, design, and human-computer interaction. In conclusion, Alan Kay's legacy is one of profound and enduring impact. His contributions to object-oriented programming, the Dynabook concept, and his educational philosophy have shaped the field of computer science and continue to inspire innovation. His emphasis on simplicity, elegance, and user-centric design remains highly pertinent in an increasingly complex digital world. As we move forward, grappling with the challenges and opportunities presented by emerging technologies, we would do well to remember Kay's holistic vision, one where technology serves as a tool for human empowerment, learning, and creativity. The vision of technology as a dynamic instrument for personal growth, a concept central to the Dynabook, continues to drive innovation in educational technology.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.